It's pink and fluffy, and it keeps us warm. Fiberglass insulation is a blanket solution for heat loss from our buildings. It has a woolly texture, but it is, as the name suggests, made of very fine threads of glass. That's why it's sometimes referred to as glass wool. It's pink, but the premise is green, because fiberglass insulation is made from at least 35% recycled glass. The recipe also includes what's called the batch, a lot of sand and smaller portions of soda ash, limestone, and other minerals. The glass, called cullet, used to be bottles and windows. This will be its second recycling. The cullet and batch ingredients spill onto a conveyor belt system, which transports it all to an electric furnace. The conveyor moves back and forth to evenly distribute the cullet and batch ingredients. They seep down and melt into a previous mix, which is now a pool of glass at the bottom of the furnace. The glass liquid now flows out of the furnace and into sloped channels. Inside these channels, the temperature is kept red hot by natural gas burners. This keeps the glass mix in a liquid form, as it oozes out of holes in the bottoms of the channels. The melted glass falls about a meter into a spinning bowl. It's called a fiberizer. The spinning action flings the glass through thousands of holes in the bowl, creating thousands of feathery glass fibers. Gas and compressed air pull the fibers, stretching them thinner. The process is a lot like making cotton candy, and the spun glass even has a similar texture. But the fibers will soon become even more like cotton candy. Nozzles spray them with a polymer glue tinted pink. The now pink and sticky fibers drop into a hole in the ground and amass. Then a conveyor belt takes the mounds of sticky glass to an oven. Steel plates compress the pack as it enters the oven that's heated to 260 degrees Celsius. Hot air blows through it, setting the glue. As the pack exits the oven, circular saws cut through it, making 38 to 60 centimeter wide strips that are called lanes. The lanes pass by a series of poles that push them apart. An inkjet brands each lane with a number that conveys the R value. R stands for resistance to heat flow. It's a measure of how well the insulation will stop heat from going through the roof, and your energy bill along with it. A chopper with big steel teeth now cuts the lanes, making chunks that could easily be installed in an attic or wall. After chopping, the conveyor belt accelerates, transporting the fiberglass bats to the next station. A few at a time, the bats plunge down a chute to a mechanical arm which slides the bats into a compression chamber. There, a hydraulic ram squishes the bats down, reducing their bulk 5 to 10 times. This compaction will make them easier to transport. Now, another ram comes from the side and pushes a stack of compressed bats forward into a spout. The spout is a hollow bat-shaped frame. A worker pulls a plastic bag over it. Then the ram pushes the fiberglass insulation bat into the plastic bag. And the process begins again. A conveyor belt transports the bat-filled bags to a machine that heat seals them. And that's literally a wrap for this production. An erupting volcano led to the invention of stone wool insulation a century and a half ago. It was observed that volcanic lava could be whipped into woolly tufts by prevailing winds. Soon, this was being replicated in factories to produce stone wool for insulation. Shaped into bats, stone wool insulation can be tucked snugly between the studs of a framed wall. It acts as both a thermal and acoustic insulator. Here's the soundproofing proof. In this demonstration, an activated alarm goes into a box lined with stone wool. When the lid is closed, the sound is contained. When it's lifted again, the annoying sound is back. They make stone wool from basalt rock and slag recycled from the steel industry. The process is fueled by coke, which is a form of coal. Basalt rock is solidified lava formed when rock melts underground and then quickly cools. After the rock has been partially crushed at the quarry, a loader scoops it onto a screen to separate the bigger pieces from the fine particles. The particles will be processed into briquettes, which can be used in the production of stone wool, along with the bigger pieces of rock. The rock and briquettes, along with the steel slag, melt into lava in a furnace. Temperatures reach 1500 degrees Celsius, as hot as a volcano. A spinning machine whips the lava into thin strands of stone wool in a process that's like making cotton candy. The strands form tufts, and a little binding solution holds them together. A spray of oil adds water repellents. Now a fleecy web, the stone wool rides a conveyor to the factory's upper level, where it spills into a huge pendulum device. The pendulum swings to and fro to layer the stone wool in a zigzag pattern. The number of layers varies, depending on the kind of insulation being made. The now layered stone wool travels between rollers, which compress it substantially, adding density to the wool. Automated pushers tuck in the pack on each side as the wool enters a long oven. The heat cures the binder applied earlier, allowing the compressed fibers to hold their shape. The now tighter pack exits through a cooling zone and travels under a roller which squeezes it to make the fibers more flexible. Circular blades then slice the moving mass of stone wool lengthwise. A branding tool burns the R value and company name onto the surface of the insulation as it moves forward. Robotic arms swing back and forth to slice the insulation to its final dimensions. Instead of sharp steel blades, these robots use high-pressure water jets to make their cuts. The jets do a precise job without generating dust or waste. And the stone wool doesn't absorb the water from the jets. The sheer density of the wool makes it moisture resistant, along with the oil added to the fibers during spinning. To demonstrate stone wool's water-repellent qualities, they pour water directly onto the surface. There's no absorption. The water just runs off. In this routine test, a worker torches the wool, and it doesn't catch fire. Stone wool can withstand temperatures of almost 1200 degrees Celsius due to its natural properties. It's even cool to the touch on the other side. Once it's passed several quality control tests, the insulation heads for the packaging line. Grippers pull on a roll of plastic tube packaging, and hot jaws cut and seal one end to form an open bag. Mechanical fingers hold the other end open as machinery slides it over a metal spout. A compressed stack of insulation is pushed into the spout. The spout expands, and the insulation is released into the bag. The spout then retracts, and the process is repeated. Machinery heat seals the open end. From a pile of basalt rock and recycled steel slag to a bag full of insulation, it's been a wild and woolly ride. If you have any comments about the show, or if you'd like